Okay, so the topic, Demystifying IoT for Operational Digital Twins. It's a real catchy title, I know, but I just made sure you couldn't ignore it after seeing it. I'd like to introduce myself. My name is Jack Strongitharm. I work at Unity. I've been here for over 5.5 years. I'm focusing on industry on a technical level in a team of many other good colleagues. Originally a civil engineer, done a lot in laser scanning and other topics, but now bringing it to Unity to do interactive content because models are mature, that people all have 3D content, so let's make it interactive. Unity is a great place to do that. I'll pass over to Daniel.
Yeah, thank you very much. So my name is Daniel Bierwirth. I'm in a similar role as Jack is. I'm a technical guy from background, actually software engineer, focused within our industrial vertical on the simulation topics and system engineering. So I'm happy to introduce you the IoT topic today.
Okay, I'm going to pass over to Adrian, who we're doing this presentation in partnership.
Hi everyone, my name's Adrian. I'm from a company called Onxr. We're a very young XR company focusing on digital twins, mixed reality stuff. And I've known these guys for some time. So we're focusing on sort of digital twins, but coming at it from a business perspective. We want to develop a business-centric mixed reality platform as well as some BEMS integration stuff. And that's where the IoT stuff comes in. So we were building a runtime for a furniture showroom in London, and we noticed that Sony Nimway sensors were everywhere. So we thought it would be really cool if we could drag that real-time data into the runtime. Spoke to Sony, they thought it was a brilliant idea, which I was quite surprised about. And so I said, yep, we'll do it, excellent. And then I thought, well, how do we do that? So I rang my mate Jack.
It's all about your friends, isn't it? Well, that's fine. Did you want to cover this?
Oh, yes. So one of the things I wanted to talk about was being able to use these templates. It really helps us as a company because it improves our efficiency, helps us deliver a higher quality work and take on more complex projects. We don't need to have as many back-end developers, so we can focus on the front end. It means we can simplify the process and we can enhance the experience. And using templates means that there's more standardization, so we can collaborate more effectively with each other. And companies like us that are growing, we don't need to spend a lot of money on back-end guys when we can use templates from these guys. And this is it. So this is a furniture showroom in London called Senator House. This is, I think this is a giraffe scan of the space. And so we wanted to build this demo system. And we took the low density point cloud from the giraffe, created a Revit model, gave it to Jack and his team, and they created the experience for us. And it was a real success. And I'd like to thank you guys.
Yeah, that's all good fun. So like IoT in Unity is not a new topic at all. And people have been doing it from first principles for quite a while. We're just jumping on the bandwagon, really. But just to point out a couple of really good examples. So this is a company in Finland called Sitawise. And here they've done a fully IoT setup for a port. So they're monitoring both the shipping, the containers, movement of vehicles, people, and everything. And everybody has a different kind of way to experience the content, being it an overall mission dashboard type experience, down to mobile apps that are in people's hands. They give them the information they're allowed to see and use to improve their knowledge of what's happening at any one time. Another good example is JCT in Singapore. So this is literally the local authority of Singapore digitizing all their assets. They make their data sets available for other people to use as well. But they also proved it out themselves. So they've got all their assets from buildings, utilities, electrics. They've also introduced robotics for like cleaner bots. And it's just, if you watch this on YouTube, it's well worth a watch. And they normally come here in Barcelona in November for the Smart Cities event. Just incredible to look at. But these guys have done it the hard way. They've worked out how to make IoT come to Unity and built all that themselves. So let's have a look at what we've done with Onxr. So we're going to switch to Daniel. You've got the view? Okay.
Okay. So don't be overwhelmed. What we are doing now is run through a setup where we basically, or maybe we switch back to the presentation and show the next slide.
Oh, yeah, sorry, yeah.
Yeah, what we didn't talk about in the beginning is the Senator House building is actually an environment where we have smart sensors inside. One of the sensors is like an occupancy sensor, so each seating area has like a sensor system that can detect whether someone is sitting there or not. Also can sense the humidity, so climate relevant information. And this is something that we connected via an IoT platform into Unity to create like contextualized visualization. So you have like a 3D representation in Unity and can see what is the current occupancy, what is the air quality, and then you can react accordingly. And this is what we briefly discussed in the beginning, where we had this Revit model, which is like a static model, and we loaded it into Unity and used the metadata that are contained within the Revit model to automatically link sensor systems to their cloud backend, so basically to their digital twin, the representation. And that allowed us to fetch live telemetry data of those IoT sensors. And here it's a GIF that we recorded, and it shows basically the live situation. So whenever someone occupies a certain area, this area turns green. But we also have an UI that exposes additional telemetry information. And this is something that you can always do yourself, but we saw that people actually struggle setting up such a simple system. And this was our motivation to provide you like a template to get started quite easily. And you might say, well, the visualization is not really that nice looking. And I guess this is something that you as experts can improve there. We focus on this technical layer, making the data available within Unity with minimal effort for you. And now I switch to the screen mirroring, what I just showed to you. And we didn't ask you in the beginning, but I guess more or less everyone heard about IoT backend. So what we are showing here now is just one example. It's an Azure IoT Hub, but it could be actually also another system. And in fact, Jack will in a minute show mqtt broker-based approach. And what we did in our template is created an abstraction layer. So if you want to visualize IoT or telemetry data in Unity, it's actually not relevant whether they are provided by an mqtt broker or if you connect to Azure or an AWS service. We just picked the Azure IoT Hub as one example. And you see here, it's a list, a lot of IoT devices. These are IoT devices that are in our Brighton office. That's part of the IoT sample project where we took our office in Brighton, loaded it into Unity, and connected the representation to the sensors. However, here in this case, they will be simulated, and this is what you see here. So I will show you how to set up basically an IoT device hub that could be like a simulator, but you could also easily replace this one with real devices. Could be like, think about an edge device or individual devices that send data to an IoT hub. And this is what you see over there. And it's just a representation, as mentioned, right? It could be something else. We just used the Azure IoT hub. And on the far right-hand side, you can see a visual representation of our Brighton office. So you might ask yourself, well, what is actually required to get all the device information in Unity? And if you work within larger organizations, they in fact might already have an IoT backend set up where all the device information are already collected. So what we see quite often is that the device information get visualized in like 2D Scala UIs. And if you think about improving the visualization, you could easily connect to your existing system, take the data, and create contextualized visualization in a real-time 3D environment. So, and to access this one, it's really easy. This is one example where we just talk to the built-in endpoint and basically get all the IoT devices that are available. And that's what I'm going to show you now as an introduction. So typically, if you want to talk to an IoT backend and see what is actually available, there is like either a public or a not public endpoint that you can talk to that gives you all device information. And from there, you could start a direct communication where you directly talk to the device. or you listen basically to device information that get published by the endpoint and then filter the one that are relevant to you. And here in our small little demo, I created a node. It's called Azure IoT Hub. And the IoT Hub Manager is really simple. It's this is required to set up the connection. So we need to know what the IoT Hub name is actually, and also need to enter the shared access key name and the access key itself. But that's basically all. And that allows us to talk to the IoT backend and use the Unity web request. So there's nothing special. The libraries that we use here, in this case, are all inbuilt within Unity. So there is not really an Azure dependency for this scenario. So you can use the web request to actually get the device information. And this is what I do now. It's not looking really nice because it's just textual information here, but I will show you in a minute then the visual representation. So if I go now in the play mode, Unity actually uses the script to connect to the IoT Hub and exposes all the information that are available. So you can see here, for example, lunch table 5, you see lunch table 2, and these are all the tables that are available in the 3D model and also on our IoT backbone, so the devices here. So this is one of the easiest way to actually get device information into Unity, but in fact you cannot really work with it. It's just a description about what is available in Unity and what the device parameters look like. So let's go a step further and show you how to set up a device from scratch and connect this to Unity. So I disable this node for a moment here, and I will also clear this one. We mentioned in the beginning briefly that the sensors are already embedded in the building model. You could even add the sensor representation afterwards in Unity directly, but the question is, if you have an automated process, how do I identify inside this building model the relevant items that you want to connect to their digital twin? And we used a simple approach where we created a device locator that allows us to set up basically names that are of interest from us that represent an actual device. So what I can do now is I maybe use this lunch table here. I already renamed this one. And I can add this into a device locator. And this, think about an automated process where you have maybe metadata, so that allows you to filter device maybe by a regular expression or maybe by what the device name starts or ends with. And at the end, you have a collection of all sensor systems that are in the building. So, and this is what you see here. So that's basically the device mapping manager that simply takes the device locator that makes sure that we find all the devices. And once they are located within the 3D building model, they will appear as located devices and then linked with the IoT communicator system, so that once a new device message arrives, it will automatically forward it to the Unity representation. So the game object that has the device representation attached. Let me start. And you should see the device that we just hooked up will appear here. Exactly. But we don't see anything yet because the device, in fact, doesn't yet exist on the Azure backbone. So we just set up like the mapping. And in the Brighton office building, you will see how automatically all different device types will appear and will be linked to the Azure backbone. So in this case, let's go back in here and maybe create a new device. And I will give it the same name because that's basically my device ID that I use to map the representation, the digital twin on the IoT hub in Unity and then the device simulator. And you can easily reproduce this one if you want to test it yourself. There is like free here, so you don't have to pay anything if you want to do your explorations. That's basically all I did. I created a device, and it's in fact currently only an empty shell. So if I look at the device, I see the parameters that I use to connect to the device. But if I look at the digital twin, it doesn't have any information that are relevant. So normally you would see all the parameters that are relevant for you. For example, could be like it's occupied or not occupied, or the temperature is a certain degree. And in case you wonder how to add the parameters, so you could do it in a digital twin, but we would rather say, and this is also what we experience by industry users, is allowing the device sending its own parameters or the capabilities that the device has to the IoT hub and then update automatically the parameters. So they will be instantly available in Unity. Could be, for example, that you have already an IoT device deployed in the field, but maybe there's a firmware update and suddenly there are new parameters available. And this can be easily achieved by telling the IoT backend what my message now looks like. And in Unity, we just use the message and then deserialize basically all the objects. And when there's an object of interest that we want to visualize, we basically map this to a shading representation, but it could be also that it's a new parameter that we add to the UI system. So what I'm doing now in here, and in case you wonder, this is a remote connection to the Raspberry Pi. And in the beginning, I showed this slide. So we're using the Raspberry Pi system. It's our booth as device simulator. So I will now go back into the browser and copy the relevant device information. So what I copy is the device name. Maybe I need to reconnect. Yeah. Let me reconnect real quick.
Live demo.
Yeah, I hope no one from my colleagues turned off the IoT hub.
Probably wondering why the robot's gone off.
Yeah. Okay, there we are. Perfect.
Right.
So I copy the device name and also the connection string. And the connection string is a secret name based off different combinations. I can also show this to you because we will delete it afterwards. It's the connection string is typically a combination of what the IoT backend name looks is defined, and also the device ID, and then you have a shared access key. So what I do now, I copy this one and add this to our remote simulator. And then I press save. So, and now I'm sending a message to the IoT hub. The message is actually in here. So the message contains the information about the device ID, device type. You always have a timestamp so that you can filter, for example, old messages that are not relevant for you anymore because it took too long to receive. And also the occupancy status and the humidity. And I mentioned that the device itself is able to update its representation, its digital twin on the IoT hub, and this is also then forwarded downwards to the Unity side. And this is what we do in this function, where we simply say, we patch our digital twin representation and add additional parameters. So if I now go into the demo and send a simple message, you see here that this is the actual message that we sent, but the IoT representation or digital twin was also updated because before it didn't contain any information. So if we look back into the device twin, we should now see all the relevant parameters that are here. For example, the occupancy that we reported, whether it's occupied or not. And this is what we use now in Unity to create the visual representation. So going back into Unity, we already added everything, so there is nothing else to set up. I pre-entered the endpoint. The endpoint is what I showed you briefly in the beginning. It's the basic Azure IoT Hub endpoint. And if I go now into play mode, the table should actually turn red or green depending on whether it's occupied or not. Okay. So basically now it turned red because we said in our simulator the building is occupied. What I can do now is maybe change the occupancy state. Okay, it's a random one. So then let's send another message. Now it randomized basically the state, and the occupancy should now be green. So what we see, the item turned green. And in case you wonder, the simulator is really simple, and we used the randomization of different parameters to test our IoT connection, and also to simulate the whole range of the sensor capabilities in our Brighton office demo. But you see what I will show to you now. So for our Brighton simulator itself, I created what I just did for the single device, for all the devices that we already have as digital twin representation on the Azure IoT Hub. This is basically the long list here where you see the reception door sensor, or also the air handling units that allow us to, for example, shade the stream that we emit in Unity based on the temperature, and also air quality. And it's a long list, but besides that, everything remains the same. So we simply send a message to the IoT Hub, and in our simulator down here, we simulate the devices by randomly shuffling the list that we created with the device representations. So this part would actually be replaced by real sensors, right? So it's just for us as a mock-up to show what the workflow would look like from sending from a real device that is somewhere in a jungle or somewhere remote that is not easily accessible, maybe even aggregated via a field device where you have multiple IoT devices combined into the Unity space. And to show you, I will switch back into our Unity editor and switch into a different scene. I just need to find it real quick. There we go. It's our IoT, oops, this one, the IoT cloud. So it's basically the same environment, but in this case, we have all sensors represented. And if I go now into play mode, you will see that the different types that we added will be populated, and also visual representation are generated. And for device localization, so if you have a building and somewhere in this building structure are devices located, you might have different entry points where you want to start searching for the devices. So that's why we replicated basically the device manager script for different game objects that we use as an entry point. So one is the Brighton office, where we locate the occupancy sensors, but we also have a separate root node here where we have objects that are actually animated, like the doors that open and close. And if we receive a message from the IoT backbone that this door is currently open, we map this into an animation. In contrast to what I showed you with the occupancy sensor, where we simply map this into a color shading. So now you basically see all the devices that are within the building model, also the doors that can be animated, and the air handling units. And if I go back here and start our simulator script, we will basically see simulated sensor data. And in Unity, we will see updates in real time without any additional coding. And this was one of the core ideas, giving you like a technical basis that you can use as a starting point to develop your own virtual representation of a real-world environment. Could be a building, as shown here, but in fact, it could be also a remote solar site or some other industry installation that you want to hook into to create contextualized visualization, in contrast to having those abstract 2D charts that are hard to understand and readable. Yeah, that's basically everything for now. I mentioned that we have an abstraction layer that allows us also to hook up different IoT backends. And with this, I lead over to Jack and show how to use the mqtt connection that is still grayed out here.
Okay. So who here has smart plugs, smart lights, Nests, other things. Yeah? Who's using Home Assistant? That's another good one. A couple of you.
Oh, yeah.
So, like with those devices, they're really good, but you have an app for them and they're all separate and they don't work together. And Home Assistant is like, well, it starts as a free capability where you can bring lots of devices together and then put some rules and various other nice things to make things smarter. So if the temperature's a certain amount, you know, turn the AC on or lower the blinds or all those kind of good ideas. But it has a very basic visualization layer, a simple dashboard, and I see some really great examples out there. But I thought, well, all this that we do for work, we also like to do for home as well. And there's no reason not to do that. So I thought I'd do a little bit of research because the Microsoft and the AWS, that's more for serious industrial cases like offices, factories, things that you need a secure approach for. But at home, you know, you can play with some different things. So I found on there something called Zigbee to MQTT, and Zigbee is a way of meshing devices from a radio transmitter here that you plug into either a Raspberry Pi or you can have a virtual machine as well. And if you look when you're looking to buy any of these kind of devices that they say Zigbee, there may be other methods out there as well, but this is one that I've tested and made available. So rather than going through the standard Home Assistant, you actually go through this panel and add all your devices. And you can also give them nice friendly names because then you actually understand what they are rather than millions of plugs. Another nice tool to look at as well is mqtt Explorer, available on PC and Mac, free tool. And what that does is it can look at the mqtt service on Home Assistant, and you can at least check that everything is working, just so you can isolate any problems maybe with Unity, scripts, and various other things. Always handy. And then, of course, Unity. So let's have a look at this for real. So let's first go on, well, in fact, go back into Chrome. There we go. Come out of the slideshow. So here's that Home Assistant running. Okay, and then obviously, so excuse this light, it was the best we could find to plug in, and you can see the stack of health and safety problems with this one. But when I turn it off and on, hopefully you see a little change there, but you also see a little blue switch changing as well. Yeah, so we know that's working, that device is working. Same, we also have temperature humidity sensor. You know, this is like 15 euros, not a lot of money. These plugs are about the same. So it's a real low-cost option. You also see that you can get some extra data about how much energy you're consuming on different devices as well. So you could also link that in to do some mathematics to calculate cost and other items too. So that's that one. And then if I go on MQTT to Zigbee to MQTT, this is where all the devices are. This is how you join them. And then come on settings. This is also where you can add those services as well. And you see the Mosquito broker. So all of this is running on a Raspberry Pi device. So really like low-end tech, low power usage. It's a great way to separate things out there. Okay, so let's go back to Unity and let's explain what we have here a little bit. So it's quite simple. But as you see here, we've got a panel here. We can see the values, so we can see 62% humidity, 24.2. It's not a cool building, is it? And humidity, well, I actually looked up about humidity and found that, you know, we should have some ranges here. So humidity should be between 40 and 60%. We are on 60, so we're on the edge of comfort. And also temperature 17 to 24, we're slightly over that. And these are values that I looked up online as recommended for office space and those kind of things. And if you look at this, we also have a range area. So 17 to 24 means that within range will be colored green. If it's cold, it'll go blue, and if it's hot, it will go red. And we're just a very simple slider, radial slider to color in. I'm going to just adjust my temperature and humidity. Give it a few seconds and we should see that go even more crazy. So that's one way to test these things. And then here we got occupancy. So I have an occupancy sensor here. So when I pick it up, it should detect me, and now it's gone occupied, yeah? So very simple. Some of these things have a small latency between when they start, so they might not always be instant. Like the smart plug is very instant. So you can see the little light. So all I've done with that one is linked, come down here. So I've got an option here. So one is to use slider, and then that's using the ranges. Or if you check use event logic, all I've got here is, again, the fields that I'm looking for, and then to, trigger light bulbs in this example here. So that's just a game object, nothing fancy. But when I turn it off, it's simple logic. And I think once you have this, you can focus then more on the experience. The visual representation, virtual reality, AR will be straightforward from this point. But we've just realized that, it's a bit like everything that you've seen in this conference this week. We are delivering to you sample projects because that gives you a way to understand how the technology is advanced, but also how you can adapt your own content and use those approaches. And we wanted to do the same here. And with Home Assistant, there is probably about 2 million users, if not more, of Home Assistant. And they could also use Unity at home for free and develop out some of these experiences, but focus on the experience and not on all the widgets on how to make this crazy thing work. But hopefully this will be useful. Okay. So to kind of conclude, we go back on here. So there is a video recorded, just in case all this didn't work. If you come around here, there is cables and network bits, because we're running mine on a local router, so not on the cloud or any of those kind of things. It's a bit of a disaster behind here. But just in case, it all worked, recorded earlier. So the other thing that we've done here is, so we've manually attached everything. But we could automate this process. And you heard Daniel saying about the metadata in the model. So if we actually we put these things in designs anyway, so like that sensor that's in the ceiling here will be in the Revit model or IFC or any of that, and it'll have a metadata tag to, whatever name they want to put to it. So we could be catching that automatically, and in our scripts could automate the connection of the sensor and then the display representation automatically, rather than manually adding it. So we need a way to obviously take this to another level of scale. So you've seen at this conference something called Asset Manager, and everybody in this room, if you're using Unity, I guess you are, that's why you'd be here, you already got access to this Asset Manager. An Asset Manager can provide the ability to obviously read CAD content, so let's just come out of here. Yeah, so this is the Asset Manager. Also to let you know, we've got some great included assets for materials and other items. We're going to add some more. There's also some demos for some models. But if I say come in, let's have a come in here, for example. Here I've got Revit models, IFC, and if you notice this 3DDS. So what we do is we can import the model onto this platform. I'll just expand this a little bit. Okay. So here's an IFC. So you can either just add one file, or here I've added a data set of 4 files because I want to treat it as one. And that would just automatically generate some image previews and even a lightweight GLB that you can view in the web browser. But we also can do prepare for 3D data streaming. And that runs a little process in the background online to break up into these 3D tiles. And you've experienced this with Google Earth. So as you use Google Earth, it's loading different data sets as you zoom in and out. And we've applied it to CAD models here. It's been available since April, and everybody with an industry license, you have this extra button available to you to generate 3D data streaming. So what that can do, so we haven't finished this part yet, but it's, it's kind of the dream. So here, we're in another sample project coming out soon, which basically can read the asset manager. You log in, read the asset manager, and then we can click on an asset. We can even download it to run it offline. We can see versions. And then when we load this, give it a second, we get our bigger model, because that's what we actually want, is to load all of it. And if I click on here, you can actually see what data is available to us. So actually, that's not the best example. Let's open another one. So you don't want to be using FBX models. If you use the raw files from Revit, IFC, etc., you'll get more. So let's just open that. You see here versions as well. So every time you update content on Asset Manager, it will bump the version. And so you can always get latest, but you can always go back if something goes wrong. So let's just come back here. And then we click on an item here. There's all that metadata. So if our objects are represented even as a little cube, as we know in Unity, or it's represented as what it looks like, we should be able to catch that metadata, and via the scripts that we've already started here is connect the dots. So that's what we aim to kind of extend the sample to, is to link it with this method, so we can then do a whole factory, a full facility of this scale, but not run out of memory, because this is very memory light. It will work in a web browser. You can push a terabyte model through a web browser now, which we could never do before. Terabyte in a VR headset with no computers, augmented reality. So this is another subject matter, but this is kind of where we're going to go. The last thing is I want you to get your cameras out if you like this talk. If you don't, you can leave. But if you'd like to get access to this project, if you scan that, it's a very basic Google form, just to give you details. And then once we've cleaned this up a little bit, made it nice for you, we'll happily send it out to you and give you access to it. And we'd love to hear feedback, areas of improvement, things we don't know, and progress together. But with that, I'd like to kind of close the presentation part and then open up for any questions you might have from what you've said.